Hello, so we've got the situation where we want to create a figure using images from a cardiac ultrasound machine. We've got cardiac ultrasound M-mode images here taken on a VisualSonics Vivo 770, and you can see we've got an image at the top, an image at the bottom. The image at the top is looking fairly decent. You can see the septal wall and the posterior wall movement, and the image on the bottom looks a little bit less functional. The posterior wall looks like it's moving a little bit less, and the septal wall looks like it's moving a little bit less as well. So what we want to do is we want to have these two images side by side with a similar scale, so the reader or the viewer of your data can determine what the differences are between them just visually. If you look at the two, and I'm just going to zoom in on the side here, if you look at the two sets of data, this scale, for instance, on the side runs from 9 millimeters focal depth down to 16.4 millimeters. And you go to the second image, and this one runs from 8.5 millimeters focal depth down to 16.7 millimeters focal depth. And this is because these two hearts are different. They are from the same subject, but they are different time periods, and therefore some remodeling has taken place in this case. And so the heart is bigger. So when you've done the ultrasound measurement, your M-mode line spans a longer distance, therefore the scale is different. The way the software, though, interprets the data is it puts the data into the same size window and therefore changes the scale here. This, of course, doesn't make a difference when you do the measurements because the DICOM images know what the scale is. But it does mean if you want to show these two images next to each other, the scales won't be the same, and therefore you can't directly compare the same two images. Rather like having two lines on a graph sharing an x-axis but having two different y-axes, it's difficult to then interpret. So if we zoom back out and have a little look, what we want to do is crop, let's say, an area of around about here, so 1, 2, 3, 4 or 5 cardiac cycles, and then have the two images lined up and scaled equally. So the first thing I'm going to do is very quickly just crop these images down to the interesting area. So let's just crop all the way, let's just do that, that's fine, and crop up to the bottom, and I'll leave that cropped there. I do the second image the same, so I choose crop and I'll crop it down. I can always re-crop it at the end, but let's just do the same kind of distance, and then just get the scale, that's fine. And there they're the same size. You saw they're lined up now, the little red dotted lines appear, and they're exactly the same size, both vertically and horizontally, so they look very nice together. So we can zoom in a little bit on those two. These are bitmap images, of course. They're made of pixels, and they're only recorded at screen resolution, so don't be too alarmed if the quality looks a bit strange on your screen, but these are not the highest quality, highest resolution pictures to start with. So we've got those two images now in the center of the screen, and I just remind you, look, the scales, if I line them up here, they aren't actually the same. And look, I've made a mistake. Look, I haven't cropped that quite as much as I wanted to, so I'm just going to go back and just crop that. Remember, on a PC you can press the control button and that'll allow you to crop without being restricted. If you don't press the control button, it likes to try and snap to existing lines. So I've just pressed the command button on my Mac here, which is the same as the control on a PC, and that's just cropped that. There we are. Now they're the same size, much happier. Okay, but you can see the scales aren't the same. So this is the clever bit. You can make one of these images ever so slightly transparent, and you can overlay it onto the other image and stretch it so it fits the same. And which one do we want to stretch? Well, this one's going from 9.5, this one goes from 10. So we have to stretch this one so it lines up with the other one. So if I go to transparency, if we stretch this one, you'll just crop it all down. So we'll go to transparency and we'll make it about 50% transparent. And we can overlay it. You can see now, you can see both. You can see the background image and the foreground image. If you find you turn the wrong one transparent, you may find you obliterate the other one. So just make sure that the one that's in front is transparent. And if you happen to do it the wrong way, you can just click on this one and bring it to the forward, or click on the right one and bring it to front. So now you can overlay them, and I can line up, for instance, the scales. That's lining up 10, and I can then stretch this image. Again, pressing the command on a Mac or control on a PC allows you unlimited stretching, and all I'm going to do is just fiddle with this until it looks spot on. That's almost there. I'm stretching from the top and the bottom, which there we go, which allows you to then line it up in the middle. So we've now got these two images perfectly lined up, and you'll see that the image on top is actually bigger than the image underneath if I hold them side by side now, and that's because the scales were different. This heart was particularly big compared to this heart. So I can turn off the transparency, bring it back to its previous glory, and now because the scales are lined up, and if we line them up horizontally again, just making sure they're exactly right, there we go. If we press the shift key, we can constrain our movement on a horizontal axis. So we've got it perfectly lined up, press the shift key, slide it across, it only moves horizontally. And now what we can do is go back to our crop tool and now crop this one down, and you'll see when it gets to that point it snaps, and the same here, when it gets to the point that lines up with the other image it snaps. Click off, and now these two images are scaled identically. And if you don't believe me, you can have just a wee look at those lines. They're all lined absolutely perfectly up. I can then crop one of the scale bars out the way, so I can go to the crop tool. Let's just remove this scale bar. Place them next to that one, and you can then compare the two. Of course, what I've done is I've actually cropped the scale bar off the one I want to show as the second figure. So I actually want this one on the right hand side, but that's no problem. I can just duplicate. I like the scale bar better because it looks neater. So I'm going to copy and paste that image. So I've got two copies of that image now. I can then crop the scale bar. My mouse is doing very strange things today. So I just crop that scale bar off the side there, and then line him up on the end, go back to this one and crop that out. So that's actually a really straightforward way of getting two ultrasound images from two different conditions, or in this case over time. Let's just crop that so it's a bit neater. There we go. And if you wanted to, then you could go back to put a text box in. So I'm just going to put a little text box in here and label it A. I could drop that in the corner there, make it white, maybe bold, a bit bigger, and I can copy and then paste that A, drag him over here, make him B, and then you've got a really nice little image. Let's move that over so it's looking a bit neater. There we go. And you've now got a really nice image where you can directly compare the walls of A and the walls of B in the same figure.